Hi everyone. We're starting, first of all, and second thing is that I completely forgot, and I apologize, that there were a fourth musical performance that I completely disregarded because I forgot that there was. So please welcome again the Oniricos.
Yay. Mom and Dad always tell me their dream is for me to get a degree, a house, a job, and someone to marry. But you gotta hurry up because time is running, and right now in my pockets there isn't much money. Who knows why their dream is not to see me happy.
I just want to be happy as I want to be.
Maybe it's not their dream, but you know what? It can be mine. Hey, you in the mirror, give me 5, you in the mirror. Let it resonate louder than anything else. More than who won't believe in you, more than who stares at you but never sees you. Be your number one fan, you'll be fine just by yourself. Remember, you won't need no one else. Say it to I'm talking to. Now give me 5. Whoa, oh, 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 oh. Whoa, oh, oh, oh. Whoa, oh, oh, oh. Whoa, oh, oh, oh. Mom and Dad always tell me you're never hanging out. Ain't you ever getting bored here? You're stuck inside this house, but don't stay away too long. Don't you care about us? Look at my colleagues' kids, they're way more grateful than you are. Who knows why? It never matters how we feel. Oh no, they never really care. But you know what I'll always do. Hey, you in the mirror, give me 5, you in the mirror. Let it resonate louder than anything else. More than who won't believe in you, more than who stares at you but never sees you. Oh, be your number one fan, you'll be fine just by yourself. Remember, you won't need no one else. Say it to I'm talking to. Now give me 5. Whoa, oh, oh, oh. 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 Whoa, oh, oh, oh.
When it seems like the world is crumbling, slowly getting twisted in front of your eyes. That's why you know what's leaving and things makes no sense at all.
Maybe I just want to live happy as I want to live.
I'll stand up and say,
hey, you in the mirror, give me 5, you in the mirror. Let it resonate louder than anything else. More than who won't believe in you, more than who stares at you but never sees you. Oh, be your number one fan, you'll be fine just by yourself. Remember, you won't need no one else. Say it to I'm talking to. Now give me 5.
the mirror.
Thank you.
Thank you.
Please do your best and good luck, everyone.
Please give another big round of applause for the Oniricos. Okay, so now they're cleaning up. This will be the invited talk section. I will leave the microphone to Giovanni Agosta of Politecnico, which will introduce all the sponsors that we talked today. Thank you.
Okay, welcome to the tech session. So the first talk will be from Huawei, and Davide Ricci is the director of open source technologies, so I invite him to give his presentation.
Thanks, Giovanni. Could you guys hear me all right? Yes. Are you guys having fun? Ready? Okay. Wow, you're so many. You know that I was one of you many years ago. I graduated from this university. It was 1920, 1930, I don't know. I'm just old. Okay, so I'm here to talk to you about open source and how open source has eaten the world in the past 30 years. I remember, you might not, so I'll tell you what happened and maybe I'll give you a couple of advice at the end. But before we begin, take your smartphone, please. Take a picture. This is going to be useful for the quiz in the end.
Because I don't get the signal in the...
All right. Can you guys see it? Yes. Let's see. Oh, look at you. Good, 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 good. Okay, keep it there for when we start the quiz at the end. Okay? Let's back to this. Okay, so open source. So it was 1980 something, and oops. So it was 1980s before the signal comes back, and Richard Stallman. Who knows Richard Stallman? Ever heard the name? You guys remember? So he was writing an editor. The editor name was Emacs. Who uses Emacs? Who uses VI? I'm a VM user myself. Right, but let's not start that fight in here, because I know it's a rough fight. So he shared Emacs with co-workers of his, and at some point a fight happened. Somebody took Emacs codes and made changes without giving those back. So Stallman figured that in order to share and cooperate, he needed to create a license. That was the born of GPL, the GNU public license. You guys know of it. So effectively, open source began as a mean to share and cooperate between friends, like what you guys do when you compete, right? And it was 1991. That license became viral, and there was a PhD student in Finland, Helsinki. His name was Linus Torvalds. You guys know for sure the name. And he was working on an x86 open source port of Minix. Minix was a famous operating system at that time, and he called it Linux, if you guys remember. Right, so Linux took the license from Stallman and made Linux GPL at that time, and this was the born of the Linux operating system, Linux being the kernel, and then all of the libraries and packages built by the open source community, right? So this led in the late 90s to what I call the distros explosions. You guys might not have been around, but I remember Mandriva, Mandrake, Debian, Gentoo, Red Hat. I was in Polytechnical. It was 1998 when I was buying my first CDs with Red Hat 3.1 on it. Put it on my computer, destroy the hard drive. The screen wasn't working. The VGA was simple VGA, I don't know, 640 by whatever. It just wasn't worth it at that time. But in less than 10 years, we ended up with tens and tens and tens of distros. That's the beauty and the problem with open source, because it gets so much energy that it gets fragmented very soon. So the question is that how is that possible that something that leads to so much fragmentation can be now everywhere? How can it be possible that it's eaten the world and be everywhere we can think of it? All right, so what happened effectively is that distro explosion led open source to become an innovation engine. Today, if you want to use open source, certainly you can build things faster than building from scratch, third of the time, fourth of the time. Expertise is greatly available. There's certainly more people knowing Python and Linux and KDE and GNOME and OpenStack than proprietary technology, right? So it's much easier to build something, and it costs less to build something, and it leads to greater robustness. So open source code is more robust, and I'll tell you a bit more about that later. So you guys are about 300, I think 300 and plus. There's about 20 million by estimate of IDC of open source developers out there. And I'm sure that you guys, some more, some less, have open source project that you guys like to work with. So you're probably part of those 20 millions. 20 millions is a lot. It's a third of the population of a country like Italy, right? And these are just the ones that are estimated. There are active developers. Right? Those who are not active developers but still work in open source can probably be many more. So think of this as the tip of the iceberg that was somehow estimated with mathematical methods. I'm sure that the signal is going to come back. Dalla regia. I'll continue. From the early starts, and you guys bear with me until the slide comes back, to dominating the world, what happened is that at some point companies realized that if I can build things much faster, if there's so much expertise out there, the cost of expertise is lower, and the software is much more robust, it was probably worth to start building products with open source technology. Okay, so it was the first industry that jumped on open source was the CPU, silicon vendors. I wonder if the software is open source, the one that is running it. It'd be much more robust. So the first industry that adopted open source was the hardware industry. Why? Right, so at that time, it was the early 2000s. If you were to buy a PowerPC CPU, Intel CPU, MIPS CPU, the early ARM CPUs, and if you were an ST Micro, the Xilinx, Texas Instruments, the only choice that you had at that time was to go to a proprietary OS vendor, strike an agreement to get your CPU working. And if you're a small CPU vendor, they just it's not worth for them to support you. And so what ended up happening is that all of the silicon vendors and CPU players, they took Linux and they started moving Linux onto their CPUs and their peripherals. And that led to proliferations of open source with any device and reference board to any device maker. So effectively, think about that. You're building whatever device, whether it's a communication equipment, a gateway, or a camera, or anything else, and when you buy the chipset from your selected silicon vendor, Linux comes in the box. Now, whether you like it or not, Linux is everywhere. Not just Linux as the OS, but all of the libraries, all of the packages, and so forth. Right, so what this led to is proliferation of Linux and open source in data centers and embedded devices. And I have some statistics about this later, right? So you can now start seeing things that started as a hobby, right, getting into the industry with industry backing. By estimate, about 8 devices out of 10 today, when you go and buy a device at Best Buy or Media World or Fnac or whatever, 8 out of 10 run open source software in there. Okay. So now if I'm a company and I need to cooperate with other companies to build open source software and we compete, and how do we do that, right? Who's the neutral party that allows me to cooperate with competitors on software that somehow is useful to everyone without us getting into a fight and still being able to progress the technology investments and innovation, right? So effectively, the fact that the CPU and hardware industry backed open source back in the early 2000s led to the growth of the open source foundations. Think of them as the United Nation, if you will, of open source development. There's many out there: Apache Linux Foundation, Eclipse Foundation, OpenStack Foundations, and so forth. The idea is that we share investment, so we share effort as company, but why don't we share investment as well? Meaning money, marketing, budget, and so forth, right? If we decide that we spend money together in a foundation, we end up spending less money individually to build open source, right? 2 + 2 = 5, 6. Not true. It's a way the marketing, talks about synergies. From fragmented ecosystem, think about distributions to drive an efficiency. If we're all working together, we cannot afford fragmentation. We really need convergence. And so the support of the foundation was incredible when it came to reducing fragmentation into convergence, right? If I'm a company, Huawei, I don't want to spend money in inefficiency. I want to make sure that every euro, dollars that I spend is as efficient as possible. From open source software, meaning a software that you put on a website with a license, we move to open source governance. So if you participate in the foundation and you are a company, you end up talking with competitors, partners, right? So who ensures that there's processes and infrastructure in place so that the information that I share is kept confidential, or rather not confidential at all, as transparently as possible. And from vendor lock-in, remember when the CPU vendor had to go to Microsoft to get a license for the OS to vendor neutrality. So the foundations helped all of the open source project to become vendor neutral. So there's no one single player that can dominate, and that's the role of the foundation. Because it wouldn't be fair if the biggest company would get the biggest share of the investment for the money that they spend, right? That's not how you drive open source forward. So since money moves the world, and if you want to take something from a hobby to changing everybody's life, open source software is the fastest growing industry of the past 10, 15 years. There's billions and billions of investment in R&D. I'm the director of the Open Source Technology Center in Europe for Huawei, and just one of the hundreds of open source developers that Huawei has as a company, right? And the same is happening at Microsoft, Alphabet, Meta, and so forth, right? Billions in R&D investment, and it's estimated that the compounded growth of the industry is more than 24% in the past 10 years, right? Year over year. So that's a big number. I don't think there's any other industry that grows as fast. Software in itself grows really fast. Open source within software grows even faster. Like if you take a look at Huawei, for instance, right now, us, like many other companies and technological company, we now compete at being the best in terms of contributions to either open source project or open source foundations. And this is just a list of all of the foundations that we participate into. I, for instance, represent Huawei inside the Linux Foundation. I'm the board member for the for the Octo project, Open Chain. I'm the steering committee member representing Huawei at the Eclipse Foundation for the Oniro project. You guys have seen all the stickers out there. Go get some if you want to know more about the Oniro project. Okay? Right, so why am I telling all of these things to you? You guys are all programmers. Raise your hand if you're a programmer. Wow, so many out there. Surprised, excited, huh? Is this some kind of competition? Right, so the way that you guys program, when you have a problem and you design it and you architect it and then you code it and you do it together and then you compete, I'm sorry to tell you, it's not the way that you guys are going to work in open source, because chances are you guys are going to work in open source. If you guys work in open source, know the difference of starting from scratch to starting from open source, right? And so the fact that open source is eating the world really has led us to a paradigm shift from the 1980s to 2022. Number one, all you programmers, coding comes last. So don't start typing. It's not the way that you start out there. The first thing that you do, if you have a problem, you look for a similar problem out there. You select the best open source project that has the best tractions and community, right? That's the starting point. Second thing that you do, you integrate. Your problem is slightly different from another one. So you integrate into your environment. You start integrating building blocks. You validated they work together. You fix what's not working. Then you code. Right? Does that make sense to anybody? It's completely different from what I used to do in the 90s, but it works. It works really well. Great programmers today are not great at writing new code, are great at reusing existing code. Second thing, it flipped the cost model. In engineering, and when I studied at the university, they kind of told me, hey, look, it costs you this much to do anything. Kind of roughly, it's going to cost 20% to maintain that over the lifetime of the project. Well, it's not true in open source, it's the opposite. It costs exactly 20% to develop a project, roughly, and 80% to maintain over the lifetime of the project itself. Why? I have the Linus Torvalds law from the Cathedral and the Bazaar, and I have more later for you guys if you haven't read that book. It's pretty interesting. Given enough eyeballs, all bugs are shallow. What does that mean? If you have a piece of code out there available for enough time and many people looking at it, you'll find bugs and bugs and bugs and bugs. And if you find bugs, what do? You'll fix them, right? And so this leads to an explosion of the cost of maintenance, not because open source software is less robust, but because there's more expertise out there that finds issues, right? That's important because it is true that it's quick to build with open source software, but the industry did not realize that the industry needed to invest more money in maintenance. The other thing that happened is no more borders, and that's extremely important to any company, in particular to Huawei. Publicly available code crosses all boundaries and breaks all export and trade barriers. If the code is publicly available, you can tell me who I'm going to be able to give it to, and you cannot tell me where I'm going to be able to copy to, and that's probably the best example of the world coming together and sharing something for good, meaning with no kind of limitations whatsoever. So today's open source software is plumbing the entire infrastructure, and effectively think of it as the plumbing that drives data. All right, what does that mean? It does mean that the business model has changed as well. We do not monetize any more software, IP, intellectual property. We share it because that's the vehicle to deliver value somewhere else. Think about it, as a service, in the hardware. That's what the software does today. It becomes the infrastructure, open source, that drives value elsewhere. That's important. If you're thinking about the next 20 years of your life, 10 years of your life, don't expect making money with a piece of an algorithm. Not going to happen if it stays in software, right? That software is going to drive value elsewhere. That's completely different from the way that the Bill Gates used to think in the 80s, right? I'm going to build this OS, I'm going to license it, attach to any Intel x86 CPU that goes out there. Every copy they make, I get $2, $5, $10. No way. We're past that point. So if you're hoping to make a lot of money with a great, fantastic piece of code, not going to happen. Right? Think about where is the value that this code can drive and think about the flow of money. And then try to monetize elsewhere, because software is not the best place. Simply because with 20 million developers out there, chances are that your competitive edge maybe has 3-month advantage. Making sense? Good. This is the example of 2 projects that we're working on, in particular at Huawei in Europe. One is the Onero project. It's a distributed OS for IoT devices, meant to be in any device regardless of the brand, to solve the issue of a fragmented IoT. And the other one is the ELISA project, which takes Linux and open source into safety critical environment like car, robot, anything like that. These are just 2 of the example. And the reason why I'm mentioning this example is that IoT is everywhere, edge to cloud. That's deep plumbing. And then the other one is connected vehicles, considering the billions of cars that are there that are going to be connected and autonomous. That's the other big part of the infrastructure, right? These 2 alone, IoT and connected vehicles, are probably 70% of the digital infrastructure of the future. All right, why should you care? Why should I care? Probably you're wondering. You should care because this drives you to adopt the egoless programmer mindset, if you will, right? I'm sure that you guys are egoless already, but that's an important concept of the cathedral in the bazaar. What does that mean? It does mean that chances are that if you have a problem, somebody as smart as you are, will probably guess, looking at each and every one of you, 300 of you in the room, chances are that they already have a solution, maybe even better done. And chances are that the opposite is true as well. If somebody else has a problem, chances are that some of you has a solution for that problem. That's the egoless programmer mindset. Don't close, share. Don't write, reuse. That's what drives efficiency, and think about where value is. And this is one of the key lessons, together with many others, that I took from the Cathedral and the Bazaar. How many know this book? How many have read this book? See, this is where the age difference shows. So you guys go read this book. There's the QR code. It's open source, of course. It talks about fetch mail and pop mail, which were the first IMAP SMTP fetcher of the early open source days, and from Eric Raymond. There's 19 lessons. My favorite ones are the next 5. Good programmers know what to write. Great ones know what not to write, and they reuse. Perfect is the enemy of good. What does that mean? When you have to deliver something, you gotta stop at the minimum viable solution for something. What's the point in making something perfect? Right? Especially if the 4th lesson is real, that users are the most important customers you have. You want to give them something before it's perfect, because you might be wasting your time. Anybody familiar with the Pareto rule, 20-80? 20% of the effort gets you 80% of the results. Have that in mind. When you're moving from university and college to industry, that's extremely important, especially in open source. You had to plan for throwing away stuff, whether that stuff is not relevant or doesn't work. Don't think that you're going to be done without making mistakes. 20% of the time, it's waste. So put in your project plan when you move in your career. And last, is Chiara in the room? Raise your hand. Look at the last one. Less is more. What does that mean? Perfection is achieved when you remove things, not when you add stuff. When there's nothing else to remove, you're closer to perfection. Okay, these are my 5 most favorite from those 19. Go read that book. It's a milestone. It's really important for you. All right? Good luck with the competition. Hopefully this is useful to you. Good luck in your career, in your life with open source software, which I'm sure you guys are going to be developing. But before we go, quiz time. So you're going to be winning 10 earbuds. Ooh, which you're going to be getting at the Onero stand, Huawei stand out there. Right? Go well, and we have big internship programs, and we want you with us for our open source projects in the future. But let's start from the earbuds. Okay, you guys should be registered already. Shall we go? See if it works. Answer fast to get more points. Oh, wait. There. Presenter mode, where is it? You guys should see the answer now, huh? Where is it? Bear with me. You guys see something from your, yes. Stay there. Okay, should we back on track? What's the estimate number of open source activate developers active out there? 248 more than 20, 12 and 15 more than 5. Somebody couldn't do the math. Square root of 100 times 10 times 6. Let's see if we can see the leaderboard. All right, leaderboard. FF, number 1. Samuel Corinas, number 2. Let's go on. Second question, ready? Let's go. Answer fast to get more points. How many devices use an open source OS? You guys are ready? 2, 1. Time's up. Right. Who's up there now? Ooh, sheep. The game. The game is top. 1,915. Sheep second. Paulo third. The top 10 will win. You guys ready? Answer fast. What does flipped cost model mean? Ten, 9, 8, 7. Hey, you can copy. Time's up. The cost of maintenance is greater than the cost of development. Yes. And let's see how the leaderboards looks like now. Ooh, the game about 60 points lead over Doni. Who's Doni? Is that you? Can't be you. Paolo third. Is that Paolo Maldini? I think this is the last one for us. Oh, 4 out of 5. 2 more. Ready? Set, go. Why do more eyeballs lead to higher cost of maintenance? Two, 1, go. More eyes, more bugs found, more to fix. Yes, correct. Let's see how this goes. The game, Samuel. Samuel took over. Paulo, where are you? Paulo, what happened to you? Last question. Make it count. 10 earbuds. Lots of stickers. What is an eagle-less programmer looking for? Share, reuse, share, and reuse. It's too easy? I know. It's about being fast. All right, so this is the final List of winners. The game wins earbuds. Who's the game? Stand up, the game. Stand up. Stand up. Stand up. Who's the game? Of course, last row. The best are always sitting there, huh? Then Samuel, Capivara, Fuergas, Brian, it's 1, 2, 3, 4, 5. Sheep, 6. Antoine, 7. Kareem, 8. Tony, 9. And it's 10. You guys, congratulations on winning earbuds. Go collect it at the Onero stand. And with this, good luck. Make the best win.
So thank you. So our next speakers are from Bending Spoons, Silvia and her team here. Let me. Okay. So please, we need to sanitize.
And the podium. Perfect. Not stressed. All right. Hello, everybody. Thanks for coming. I'm just gonna do a little dance. It helps me relax. Right, but my name is Lucas. Thank you so much for coming today. And thanks so much for taking the time to listening to us talk. With me today, we have Silvia. Silvia is the head of our engineering recruiting team. She's absolutely amazing. Also have to say that because she's my boss. And then we have Andrea Trecarico, who is one of our back-end engineers as well. And in the back, Katya, who manages our branding. She's standing there to make us all look super pretty. And yeah, I'm Lucas. I just started working at Bending Spoons 9 months ago. It's been an absolutely incredible experience, and I'm here to tell you about it. So first, who are we? Bending Spoons was founded in 2013 by 4 Italians who, for some reason, decided to found their Italian company in Copenhagen. Probably because they were studying there, but also still a weird reason. And now we are back in Milan, but our mission has continuously stayed the same, and it is to create the most wonderful company in the world. Of course, we kind of realize this is a super lofty goal, but it really helps us shoot for the stars and make sure that we're creating products that are absolutely incredible. In addition to that, we want to make sure we're also creating the best workplace on earth as well. So a place that anyone, regardless if they are engineer, regardless if they are recruiter, can call home. We find that really important, and that's one of our top values as well. So hence, we created this company, Red Bending Spoons. Is a software development company, and we specialize, right now we have a focus in mobile apps, both Android and iOS, but we are also touching around in other areas, and Silvia will cover in more detail kind of what types of engineers we have in our company. To back up kind of some of the stuff that we're saying, of course, right, we have these super lofty goals, but we kind of are hitting these milestones, which is continuously motivating us to improve. In 2019 and 2020, we received the Best Place to Work in Italy, which for 50 to 149 employee category, which is a really amazing achievement. We've also received awards for Best Place to Work for women, millennials, and then this year, our company has grown quite a lot. So we are just around 300 employees, so we switched categories, and we actually ended up second for Best Place to Work for companies 150 to 300 employees, which is quite the achievement. Of course, we're super happy about it, but it's just a milestone, just a benchmark to keep motivating us to do better. So, of course, as I said earlier, we want to create the best company in the world, so we want to create the best products and make sure that they're appreciated by users all over the world. Some of these products include the ones that you can see on the screen over here. Splice is our most flagship app. It is a mobile video editor. Then we also are focusing right now on Remini. Remini is a photo-enhancing application powered by AI and machine learning, and we actually just started an AI team, which Sylvia will go into more detail with, but they're working on things like photo enhancement, image recognition, which is super exciting. And then we also have our Fonts app, which is an application to make cool little creations on your keyboard to text your friends, so you don't have to use the normal boring Apple or Android keyboard. Another important point we like to touch on is we don't have clients. What does this mean? We produce all of our apps for ourselves. The reasons we do this is because we want to make sure that we are having direct communication with our users, so we can ask them, what are you looking for? How can we make this app better for you? And provide features that are simple and easy to use for them, but also really powerful and kind of give them the capability to create in giving a lot of freedom and a lot of power to the user as well. How do we do this? We have kind of our process here on how we create apps. We also have a super cool, to touch on, product exploration team whose sole job is to be our startup within a startup, and they basically go out and find really interesting opportunities and explore those and create apps actively for our company to explore and build upon. And right, we do everything in-house. That includes our tools and technologies. So we build a lot of our tools, technologies, libraries for our applications all in-house. Hence why not the only engineers we need are mobile. We also need a bunch of back-end web developers, front-end developers, full stack, everything across the board. To kind of back up what I've been saying about us really pushing this goal of being and creating the best products, we have some numbers just to give you an idea. We have right now around 500 million total downloads, just about 60 million active users monthly, and around 500,000 downloads per day, which is making us one of the top leading iOS developers in Europe. Again, something that we're super proud of, but it's just pushing us to want to do more every day. Right, as I said, we're just getting started. We really want to continue to kind of push the envelope when we're talking about what technologies we build, kind of what we're doing with our applications, where can we create an impact, where can we build an environment to really enhance the life of our users. And how do we do this? We have kind of our 3 pillars in Bending Spoons: people, technology, and data. So the first one, people, as you can see, we have some of our incredible spooners here. But something that I find really, really incredible that I like to mention when talking about Bending Spoons is we are incredibly diverse in mindset, in nationality, kind of the way that people think at our company is incredibly unique. Every person that you see in Bending Spoons, you can have a conversation with that has a different point of view, and you have the opportunity to learn something, which I think is one of the key points as to why we are so successful. We just have all of these really, really incredible people working with us, and yeah, right, from all over, incredibly intelligent, but again, we just look for people with different mindsets and who have the desire to create an impact, build a dream, and make a change in the world. In addition to that, we have technology next. So consistently, we're trying to push the boundary on that. We want to make sure that we're not just building an app that's like the ones that we've done or that we've seen. We want to make sure that it's better, faster, create tools and technologies that optimize and allow specifically our applications to really, really grow rapidly and give our users the opportunity to build and create that impact with our applications as their tools. We want to create something different. We want to create something new. We want to create something exciting. So we really want to continuously pushing to optimize, move things faster, make them better, and make them more easy and interactive for our users. And lastly, data. At Bending Spoons, regardless of what team you end up being a part of, there is going to be a data-driven approach. Any situation that we can kind of get some input on from data, so that ranges from what features on our applications are being used more, kind of which buttons we should be focusing on, which UI looks better than the other ones with A/B testing, to even in recruiting, we do a ton of data analysis. It's kind of everywhere in the company, and it's kind of a very centerpiece of what we do, and we're continuously pushing that. And lastly, before I leave you and have Sylvia, the better version of me, take over, I just want to really encourage you to come up and talk to us during this event today, tomorrow. We're super excited that you're all here, and we're super open to telling you what was our experience at Bending Spoons, what is our experience, and why is it this company that we all absolutely love, that we spend time with the people that we work with outside of work. Why do we constantly just fall in love with working at Bending Spoons every day? And I really encourage you to come up and ask us those questions, and we'll be more than happy to tell you. So now I will hand it over to Sylvia, who will touch on the next portion.
Hi again. So I would like to give you a few insights of some of our business area in Bending Spoons, starting obviously with recruiting. This is my area. I'm a recruiter in Bending Spoons since 2.5 years now. And as Luca was saying, we really think that one of the key to our success is our team. We are trying to build the best team possible, and to do it, we are really focusing for new spooners, either on knowledge and skills or potential, which means that we are looking for people that are great at what they do or that can grow to become great at it. We really focus on talent, we really focus on passion, We don't ask anyone that joins Bending Spoons to have specific knowledge. We are ready to teach everything that is needed to bring the gap with our team, but definitely we are looking for people which values align with ours. So people that are eager to learn, that are ambitious yet humble, and great team players. The other area I would like to present today is product management. As Lucas anticipated, we have focused so far mainly on mobile apps. And our product teams, we are focusing to create, our product teams focus on creating the best products appreciated by users all over the world. The products we create our own. We don't have clients, we build just for the final users. And we focus, our key levers are gorgeous design, usability and functionality, and data analysis and feedback. This is mirrored in how we organize, how we work. Our product teams has inside of them all of the profiles, all of the figures that are needed to create, release, maintain the app in the store. So we have all together developers, marketers, product people that work super close with each other. And this is also how we work. I mean, the flow is circular. There is no one moment for ideas, one moment for prioritization. Everything flows. We have tons of ideas. We have teams that focus only on product exploration. We are constantly focused on exploiting and exploring opportunities. Last but not least, software engineering, which is probably the area you are more interested in. Yes, we have focused so far on mobile apps, but this is not the only things we do. That's why our engineering team consists in many different types of engineers. iOS, Android, but also backenders, machine learning and AI engineers, web developers, security engineers, infrastructure engineers. Why? Because we focus on apps. You can see the icons of the apps that Lucas already presented, but we also try to build in-house our tools, our frameworks, our libraries. My suggestion, take a look at our GitHub page. You can find some of our open source projects and have a look on how we code. Here you can see the logos of a couple of our libraries, Katana and Tempura, and one of our data tools, Pico. Our key levers when it comes to engineering are code quality, attention to detail, automation, and testing. But this is not all, because now we have a few of other fields we are just getting our toes into. Mainly AI research. In late summer 2021, we launched our own AI team that is growing super fast. Now it counts 20 members and combines experience at Facebook, Google, Adobe, Disney, and more. The team is divided into functions: AI science, that focus on discovering groundbreaking technology and applying cutting-edge research to products, and AI tools, that instead focus on reducing time to market by implementing and maintaining an efficient infrastructure and toolkit to support AI at scale. The team goals are mainly infrastructure, so optimizing the flow between research and deployment, product, deploy AI features to the app based on the product roadmap, and communication, publishing research, collaborating with universities, speak at key conference. And talking about conferences, we also decided to sponsor one of the first conferences in Italy related to AI. The conference will be held this July in Milan. It's called Synapse. Registration are open if you're interested. And this will be the chance to meet and discuss relevant topics related to AI with globally respected voices in the field. Among our confirmed speakers, there is Max Tegmark, which is currently a professor at MIT. Something new again, algo trading. We have our own algo trading team that focuses on trading in any sizable market to deliver exceptional risk-adjusted returns of investments. To achieve our mission, we are leveraging our three fundamental pillars: scientific research, cutting-edge technologies, and selfless teamwork. This is allowing us to create exceptional risk-adjusted returns on investment, identify profitable strategies with arbitrage and machine learning, and fully automating profitable strategies and scale volumes. We are mixing new approaches, adding new trading functionalities, and creating new types of crypto exchanges. And at the same time, we're trying to improving and developing our current strategies and doing more research on general market dynamics. This is all, but if you are still curious about Bending Spoons, about us, please take a look at our manifesto, when you can find all of our values, our career page, when you can find all of the opportunities that we offer in Bending Spoons. There are mainly possibilities for internship and also some graduate programs. If you are not sure what you like and you want to rotate them on some of our business area to discover them and pick the one you're really passionate about. And here also another couple of links related to event we sponsor. Mainly signups, I already mentioned it, but also First Ascent, which is a retreat for computer science students, both Italian and European. We have 2 different editions. Now applications are open for the Italian version, but in October we will reopen application for the European one. And Transcend, application will open in a month. Transcend is a 6-month mentorship program for computer science students. So thank you all for your attention. As Lucas already mentioned, I'm here to answer all of your questions. Lucas, Andrea, and Katia also. So feel free to ask now if you have anything you're curious about, or just come talk with us at the stand. If none of these works for you, there are our emails. Just feel free to reach out in any moment. Thank you. I think there are no questions. Thanks again, and best of luck.
So, thank you. The next talk will be streamed over Zoom, so we have a couple of seconds of delay in order to get the technical part ready, and then we will be ready for the talk from Jane Street. Okay. Okay, here we are.
I can see myself, so I'm not sure if that's a prompt for me to get started.
Okay, we should be ready. Can you hear us? Let's see if so we can hear better, but apparently they cannot hear us. Hello?
Ok, glielo scrivo in chat, ci vedranno tutti.
Okay, hopefully you can hear me now. Yeah, I'm going to go for it. So, you can hear us? Okay. Firstly, morning everybody. So good to see so many of you sort of there in the room. A big welcome to the Southwestern Europe regional contest in Milan. I'm Beth, I work at Jane Street in our recruiting team, and we're just really delighted to be the gold sponsors of the competition this weekend and see how you'll get on. It sounds like you've got a really packed schedule and lots of fun things ahead. We are extremely passionate about competitive programming at Jane Street. Many of our software engineers at Jane Street took part in different competitions throughout their student life, and so we're always glad to have the opportunity to support and take part in competitions like this. As I say, my name's Beth. I work in the recruiting team at Jane Street in our London office, and I'm joined by my colleague Gabor, who hopefully you can see on the screen as well. Gabor is a software engineer at Jane Street and also thinks a lot about our recruiting processes as well. We're really sorry that we can't be there with you in person today, but we're really glad that we can spend a little bit of time with you this morning. Our aim from the time that we have together today is to share with you a bit more about Jane Street. I'm going to hand over to Gabor in a minute, who's going to tell you a bit more about Jane Street and software engineering at Jane Street, and then we'll head over to the Slido, which hopefully many of you have already received the link to, and we want to answer some of the questions that you've been sending in. In case you don't have the Slido link or didn't receive it earlier on, the Slido number that we're using today is 280413. So with that, Gabor, I will hand over to you.
Brilliant, thank you very much. And hello everyone, it's great to be here with you all. As Beth said, my name is Gabor, and one of the software engineers in Jane Street's London office. And indeed, one of the pies that I have my fingers in is a lot of our hiring efforts. And that's basically why we're here to talk to you about. So I guess many of you might not be familiar with Jane Street, so I thought it might be helpful if I just say a couple of words about what we do as a business. We are a proprietary trading company. That is the big fancy word that is kind of our official definition. But what it really means is that we are a trading company that trades various financial instruments with our own money. So that's very different from a bank, for example. Our primary business is not to have people come and store their money with us. We're also not like a pension fund or a hedge fund or something like that. Our primary business isn't for people to come and give us their money so that we can make a profit for them. We are doing all of what we do with pretty much our own money. And the primary service that we provide, to the world is what's called providing liquidity. Which is probably best understood through an example or an analogy. So you can kind of think of Jane Street as a supermarket of the financial world. Imagine when you go into a supermarket, you can always get fresh tomatoes, even if you go at 6 a.m. and even if you go at 10 p.m. in the evening, even if you go in the winter and even if you go in the summer. And that's pretty amazing. Like, that's not how tomatoes grow. I don't know how much you guys know about farming, but like, normally they don't grow throughout the whole year unless you do some things with greenhouses and all that kind of stuff. But those don't tend to be in London, certainly where I live. So if I walk into a supermarket in London and I can get a fresh tomato, that's because the supermarket has links to many different farmers in many different places. It does careful inventory management, and it makes sure that, I get to have those fresh tomatoes whenever I want them. And if I want to make a sandwich, then I can get my fresh lettuce, my fresh tomatoes, and all the other things in one place, easily and conveniently. And so I don't have to like go to different farmers markets and go around and talk to 10 different farmers and figure out who has the best produce. I can get it all in one place easily and conveniently. So how does this analogy actually like translate to finance? What a company like Jane Street does, what providing liquidity means, is that we're always willing to buy and we're always willing to sell absolutely everything up there. I guess this is something that we do similarly to supermarkets for a little bit of a profit. We tend to sell a little bit higher than what we think a thing is worth and tend to buy a little bit lower than what we think a thing is worth. But it actually might still work out to be cheaper, and certainly you're probably happy to pay a little bit extra for the convenience. So how does technology come into all of this? Why does a technology company need competitive programmers? Why does a finance company need competitive programmers? And the answer is because we're as much of a technology company as we are a finance company. Trading is an electronic business. The timescales in trading nowadays are very varied. You know, some trades might take weeks to execute, but many other things happen in the order of microseconds. Humans aren't very good at doing things on the scale of microseconds. We need computers for that. Similarly, we deal with a huge universe of different financial products. Imagine that we price every single day throughout the whole day more than 5,000 different ETFs. Those are just one particular type of financial product that we trade. And we have less than 2,000 people working for us. Well, we couldn't possibly do that manually. It's also a highly competitive business, which means that speed matters, both the speed of getting new ideas out there and being able to do them quickly, but also the speed of being able to execute those things quickly every day. We deal with massive volumes of trading. Every day we execute many millions of trades, even more kind of various activity that doesn't necessarily lead to a trade. Again, how would we possibly do this without computers? And it's also a very risky business. We are trading on our own money, which means that if we mess up and we lose all of our money, then we're out of business. So all of these things mean that we have a pretty unique and interesting technology stack because it has to cater for all of these problems. It has to provide high throughput, high availability, low latency, and a very low tolerance for errors. We do this through many different techniques, but maybe the most the biggest thing that we're famous for is that we use OCaml, which is a strongly typed functional programming language to do all of our software development. And that we believe is a huge help in reaching all of those goals that I mentioned. But obviously, we also depend on hiring amazing programmers to help build all of those systems that we need for all of the trading that we want to do. We always have more trading ideas than what we are actually able to execute on because we normally don't have the ability to actually program all of those and actually build all of the systems that we need. So we're actually very excited that some of you might consider joining us in some way or shape or form, for example, through our internship program. And Beth, I'm going to hand back to you to say a couple of words about that.
Thank you, Gabor. So yeah, as Gabor's sort of already introduced, one of the main ways in which you can get to know Jane Street a bit better and certainly spend time with us is through our internship program. Our internship program is also one of the main routes to full-time positions at Jane Street as well. So primarily the internship program is designed for students that are in their penultimate year of study. So that is, if you wanted to do an internship next year, you would be expecting to graduate in 2024. And it's usually a program that runs between 10 and 12 weeks over the summer. And depending on where you have sort of the right to work or where you would like to be working, we would imagine that most of you that we're speaking to today would take part in one of those internships in our London office. The internship we put a lot of thought into and a lot of planning into. The whole program is designed to be educational, so that at the very least you're going to leave your time with us over the summer having learned something with us, but also we do put a lot of time into making sure that it's really good fun over the summer as well. The primary sort of like technical things that we're looking for you to learn during your time with us is firstly to learn OCaml, which we'll talk hopefully a little bit more about in the Q&A, and also learn more about Jane Street's internal libraries. You'll really get the opportunity to work on real projects with full-time employees who are ultimately going to be the end users of the products that we create at Jane Street. We have extensive classes throughout the summer and different external speakers who come in to talk more about technology, trading, and other topics as well that are relevant to what we do. In addition, we have a mentoring program so that you feel well supported throughout the duration of your time with us. And finally, maybe not most importantly, but we do also have extensive social events that we plan throughout the summer. It's a paid internship, and we also provide accommodation for you in London if you chose to do your internship there. We can hear someone talking there, so I don't know whether... we might have someone else on. Okay, sorry, I'm going to continue. In terms of application timelines, applications for our internships open in the August of the year before you would be planning to do your internship. So unfortunately for this summer, our internships are full, but we will expect to open our internships for next summer around August. I would encourage, if you're interested in applying, that you do apply soon. For software engineering, generally, we will expect that our internship roles will begin to fill up around Christmas time or into January. So you can actually head to the website now, and if you go to the internships tab, whilst you're not able to apply, you can register your interest so that when we do open those programs, you'll be the first person to be alerted to that. I also wanted to plug one of our programs that we have coming up, which is called Preview. So we offer quite a wide range of different programs that are designed for students who are not in their penultimate year of study to learn more about James Street. And the next relevant one that we would have for most people in this audience is a one-day program that we've designed to give you a very light touch introduction to how we use technology and maths at James Street. That program is going to run on the 6th of May virtually. Technically, the applications for that actually closed yesterday, but knowing that we were coming here and talking to you all today, I've twiddled a few things and we're going to leave it open over the weekend. So if it sounds like something that you want to learn more about, then please do take the time to go over. I know you're very busy this weekend, but try and take the time to go over and apply for that preview program. It's on the programs tab of the website. So with that, I know there's some really great questions that have come through on the Slido. I want to make sure that we spend the time answering the questions that you've been asking. Again, the Slido code is 280413. I can see the most upvoted question is technically not a question, even though there's a question mark there, which is, I just lost the game. I would technically say that was a statement. But I think the next upvoted question is, what interesting algorithmic challenges do you face at James Street? And Gabor, I think you are definitely better placed than me to answer that.
I'll at least try. Yeah, we do plenty of things that end up being difficult from an algorithmic point of view, and it might come from a wider bucket than what it might initially be like. So there are a couple of different categories that are worth bringing up. There are some problems that are just like inherently hard to understand well enough to be able to design an algorithm for. Not to mention an efficient algorithm. We have some tremendously complex problems in the space of finance, and it sometimes takes a great amount of sort of insight and hard thinking to be able to even come up with some kind of like good algorithmic approach to them. Then obviously there comes the question of how do we actually come up with an algorithm that's efficient enough that we can actually meaningfully use it. Many of the decisions we have to make have to happen on the scale of, certainly sub-second scales. So we can't have sort of, I don't know, like exponential time algorithms running on huge data sets. We deal with very large data sets. That's another kind of reason why many of the challenges we have are related to performance. So it's not always about latency. If you just think about the fact that we kind of eat information about all the trading that happens in like most of the big trading venues throughout the world, throughout the whole day, that ends up being a hose pipe that's many, many gigabits per second of information that we have to kind of process in real time, update all of our models in response to them, and then kind of act in our trading kind of in response to all of that. And that kind of also hints at maybe a third area where we have quite interesting algorithmic problems coming up, which is the area of sort of distributed systems and kind of distributed problem solving. Generally, the scale of our technology systems is such that we can't possibly make use of a single computer to solve many of the problems that we have to solve. We can't do that for performance reasons. We also can't do that for availability and reliability reasons. So actually, many of us at James Street spend an awful lot of time thinking about distributed algorithms and kind of resilience, fault tolerance, all those kind of attributes that make a distributed system useful. So I think those three areas are the kind of main ways in which algorithmic complexity kind of creeps into our work.
Great, thank you very much. And another question, we touched on OCaml earlier on, I think, in the introduction, but Gabor, if you can maybe provide a bit more context as to why we do use OCaml, and specifically the question that's been asked is, why do we write OCaml when C++ is faster?
Oh, that's a tough question. I don't know if I agree with the question, for a start. I think the question might be lying, or at least certainly kind of making a statement that needs a little bit more justification. I think you can write fast OCaml code and you can write fast C++ code, but if you naively write either of those, they're probably not going to be very fast. So in a sense, I think maybe C++ is more traditionally associated with trying to squeeze out the last ounce of performance from your systems. But actually, a lot of that comes down to kind of how much you know what you're doing, how much you're sort of able to optimize, how much you have the tooling to understand the performance of your systems and kind of adjust them accordingly to improve performance. So we use OCaml not primarily for performance reasons. We use OCaml because we think that the functional nature of it and the strongly typed nature of it make it much easier for us to quickly write correct code and to understand the code that our colleagues are writing, which is a very important thing at Jane Street, given all of our work is very highly collaborative. It's very common for one person to write a piece of code, someone else to then modify it, and a third person to come around and look at it a couple of days later. But I don't think the claim that OCaml would be like inherently slower is necessarily true. OCaml compiles down to native x86 instructions. The compiler doesn't do maybe quite as sophisticated optimizations as some of the C++ compilers that have been around for a while, but it does do some pretty good things, and we are actually working on improving a lot of that kind of stuff day to day. There are people at Jane Street whose expertise is kind of compiler backends, and they're looking into how we can make all of that better. And in a large way, how you write your code, I think, tends to matter more than what language you write it in.
Great. Thank you. There is a question here that I guess I don't know how well placed you are to answer this, Gabor, but we'll do our best. So obviously, I think it's often very common that students will think about interning in FAANG companies. Someone's asked the question, why finance over FAANG companies, and what do you think are the key differences between the two? And I say this, and I can't remember if you've worked in a FAANG company, so I guess we'll have to preempt our answer.
But maybe just for anyone who's not aware of that wonderful abbreviation FAANG, I guess we mean normally sort of big tech companies, so like the Facebooks and Apples and Googles, and I don't even know what N does. The N stand for Netflix or something? Whatever. Anyway, like why would you work at a big tech company instead of Jane Street, or why the other way around? Clearly, I don't have a personal perspective to share. I have never worked at one of those places, but I think there are some key differences. We do not deal with retail clients, for example. Like a big difference, I think, is that most of those big tech companies happen to be big tech companies because they kind of serve individual customers throughout the world. That's not our business. You as an individual sitting at home don't get to directly interact with Jane Street. All of the people that we trade with are professionals in finance. And I guess what this means is that some of our scaling problems are a little bit different. It means that we're not trying to scale web services to be kind of accessed 20 million times every second by people from 100 different countries. We are often trying to scale individual systems to handle much larger loads because of the sort of technology intensiveness of finance that I mentioned. So in a sense, we have the kind of a very similar amount of technical challenge, but we have that in a slightly different shape and form. We don't tend to care about sort of availability the same way that those companies do. For a global company, missing out an hour of availability on their web application or something any time of the day is pretty bad, sort of comparably bad to any other time of the day. For a company like Jane Street, a trading company, some times of the day are just much, much more valuable than some other times of the day. So that kind of changes our thinking around risk, for example. It changes how we think about when we can upgrade and roll systems. So there's I think those kind of like technical differences. Also, there's something about finance just being a very like inherently interesting field to work in. And this is where I don't get to make a personal comparison because, as I said, I've never worked at one of those big tech companies. But finance in and of itself turns out to be a place where maths and the kind of like rigorous thinking that programming encourages you to do tends to be really helpful. Like I think I had some ideas that before working at Jane Street that finance was mostly kind of a boring kind of line of work for people who had very different interests from me. But actually, most of the people who work in trading at Jane Street have a maths or software engineering or physics kind of background. And that's not an accident, because it turns out that quantitative finance, our sort of brand of finance, where we try and use the tools of maths and science to deal with finance, is actually a really interesting and challenging kind of field to work in.
Great, thank you. I know our slot was only due to run till 11, but since we got started a couple of minutes late, I'm hoping that we can just ask one or two more questions. There's some really good questions coming through on the Slido. Matt Parker, sadly, is not with us today, although we are very big fans of Matt Parker too. For those that don't know, Jane Street do sponsor Matt Parker's YouTube channel, so do keep checking that out. There's another question in the poll. Gabor, again, I think more for you to answer, and you've touched maybe on this slightly, but what kind of concrete problems do you solve, and how do, I guess, competitive programming skills come into play? And I might just add sort of another question onto that, if you can expand that into the interviews, and like, are there any elements of competitive programming that could be helpful for interviewing?
Yeah, absolutely. I guess in a sense, our business is not competitive programming. When you're doing competitive programming, you're optimizing for some things that we don't want to optimize for. When you're kind of in your working life, working for a company like Jane Street, it's fine to spend twice as much time writing the code. And particularly if that makes the difference between having a 1% chance of having a critical bug versus a 0.01% chance of having a critical bug, then we definitely want you to spend that extra time writing that code. So in a sense, that side of things is not actually very similar to programming competitions I've taken part in. But what is very similar is that the problems tend to be algorithmically challenging. Like when we talk about what kind of problems we solve, I think it would be hard to go into like very concrete details, but you can imagine that a lot of the shape of our problems is that we have an understanding of what certain things in the world should be worth. We see some evidence of what other people value those things at because they're willing to buy and sell them at certain prices. Then we have to update our understanding, and we have to figure out what we want to do with the things we already own, whether we want to buy or sell more. That is the sort of like heart of a trading company. That's the sort of like flavor of many of the algorithmic problems that we're solving, although I guess there are some sort of more purely technology focused ones as well, particularly in the kind of distributed systems area. How is this similar to our interviews? I think that was maybe the other question or something like that. In a sense, we try and make it not that similar. I guess we want our interviews to model the real work that we do at Jane Street. We want you to get a real sense of what it might be like to work for us from the interview process. So we try and, for example, propose questions in our interviews that actually aren't that algorithmically challenging. I think one of the difficulties with sort of asking someone a hard algorithmic question is that they either have the good idea on the spot or not. And if you were to ask them that same question again the next day, maybe they would just have that great idea that they didn't have the day before. And because we often don't have that many chances or don't have that much time to kind of meet you and get to know you, we don't really want to kind of have that much risk in the process. So the questions we're going to ask you are going to be challenging, but they're often not going to need a kind of light bulb moment where you suddenly realize what is just the right algorithm to use it. And if it does ever need that, we might just tell you that. We might just have a chat with you as if I'm your interviewer and say, actually, have you considered using this algorithm or that? Because that might be a good way to solve the problem. I think in a sense, what is similar is that unfortunately, all interviews have time pressure, no matter where you're interviewing. Your interview is going to be an hour long, an hour and a half long, 2 hours long, but it's not going to be 3 weeks long. So the skills you're picking up by being able to kind of quickly think through a problem, quickly analyze it, quickly come up with an approach, then write out some code is going to be very helpful in applying for, I think, any kind of software engineering job. And that's certainly true at Jane Street as well. And it seems to have been true historically for many of the great competitive programmers who've come to interview with us and who we've managed to hire.
Great, thank you. And very last question, which I think is quite straightforward for us to answer, and then we'll wrap up. Somebody's asked the question, is it necessary to have any previous knowledge of trading or finance to work at Jane Street as a software engineer?
Great, the answer is no. I personally had absolutely no previous knowledge of finance or trading. In fact, I'm really bad at trading. I don't know if we both think about this, but I've taken part in one of our internal training programs, and it really became obvious that I'm a much better software engineer than I'm a trader. And that's fine. I think there are some people at Jane Street who are exceedingly good at both of those things. But if you're interested in technology, please come and talk to us and please come and work for us. If you're interested in trading and you don't care about the technology, please come and talk to us anyway. The both of those kind of people get along really well and have fulfilling careers at Jane Street.
Great, thanks, Gabor. And I think even though Gabor there specifically was referring to the software engineering roles and how we don't look for finance experience for that, the same is also true for all of our internship roles, whether that's quantitative research, trading, or business development. So as Gabor says, even we're not expecting any finance experience, so please do come and have a chat to us, regardless of your background. So with that being said, we obviously don't want to throw you off. I believe that you've got lunch next, and we wouldn't like to take any more of your time than we already have. We really hope that you've enjoyed learning a bit more about Jane Street today and the different opportunities that you have to spend time with us. We would love to spend more time with you. So I guess two main calls to action for those that are interested in learning more and spending more time with us is that preview program. So again, go to the janestreet.com website, navigate to our programs, and you'll find the previews there and should still be open for applications. And other than that, you can register your interest for 2023 internships. We both wish you the very best of luck over the weekend. We can't wait to hear how everything goes, and hopefully we'll see you all, or at least some of you, at programs with Jane Street very soon.
So, thanks to Beth and Gabor for the nice presentation. The last for today, but we need to...
Let's take a tour through some of the hyper-productivity features of C-Line.
Wait,
now imagine we're coding up the knapsack algorithm.
I will need to re-switch to... So the last technical talk is from JetBrains, so I will just leave it at them.
Take a tour through some of the hyper-productivity features of C-Line. Now imagine we're coding up the knapsack algorithm. We can make light work of these for loops using the bundled live templates. Now we need to assign a value to the current cell in this array, but we need to do it in different ways. Well, it's easy to wrap a statement in an if-else, as well as several other surrounds with templates, without breaking out of our flow. Now let's do the else branch. And here we're seeing red because we've used max without including its header. And which header is it anyway? Well, alt enter or option enter not only tells us that it's algorithm, but will even write the include for us, without us ever leaving the line that we're on. Now this branch is getting a bit more complicated, with lots of repetition. Well, we'll sort that out in a moment. But first, even this is conditional, so let's wrap that again. And now that's the final branch, so let's look back at that repetition. We see this expression here several times, so we can extract that as a variable. And similarly with this wait one that appears twice. We might want to do the same with value for symmetry, but actually that's our complete algorithm, written at lightning speed by making C-Line do a lot of the work for us. Let's go back and look more closely at live templates, which we can find in the settings. These three bundled templates expand to common for loops, like the one we just used, as well as range-based or iterator-based loops. But we can add our own. For example, to make a quick way to get the size of a C array, we can use this pattern. But how did the for loop template fill out our loop variable? Well, if you click on edit variables, we can see that some template variables are mapped to internal functions, which give us useful results, like suggesting an index name here. If we go back to the iterator for, we see this right side type, which deduces the type from the right hand side of the expression. Or we can let auto do the work. So consult the docs page on live template variables for all the things you can do with this powerful feature. Now, going back to the code, C-Line can tell you immediately if there are problems or potential problems with your code with its powerful inspections. These come from both ClangTidy as well as C-Line's own internal analysis engine. In many cases, it will also offer a quick fix. So commit Alt-Enter or Option-Enter to your muscle memory because it can fix or write a lot of code for you. Remember, we used it earlier to add an include. Now we can easily comment out blocks of code with a single shortcut and uncomment them just as easily. But what if we wanted to change all of these equals operators to less than or equal? Well, we could do a search and replace, but that can be fiddly. A more direct way is to use column selection mode to give us multiple cursors. Of course, if we do want to find and replace features, well, let's look at a larger codebase. We can find and replace in a single file, of course. But it's when you do find in path or replace in path that you really get the benefit of C-Line's indexing to give you immediate results. Because of that index and understanding of the code, we can do more structural searches. Search Everywhere is your gateway to this, and either from there, or with its own shortcut, Find Action will even search C-Line itself for menu items and shortcuts. So if you don't remember a shortcut, you can still get to an action quickly this way. Or if it doesn't already have a shortcut, you can assign one here. This local history, by the way, is a great way to get many of the benefits of version control without ever having to do version control. Think of it as undo on steroids. So that's just some of the features C-Line offers that can give you an edge in highly productive coding.
Okay, this was the last technical talk. So now Dario, the co-director, will give you some directions for the lunch. So Dario, if you can please come.
Hi everyone. So now is the time for lunch. And you have on your badge the turn for your lunch. There is A, B, and C. Today A is first, tomorrow A will be last. So everyone who has lunch turn A can either go by themselves to the cafeteria. Otherwise, there will be volunteers. We will accompany you. We will form a group outside and go to the cafeteria. Okay, see you later for the next event. I think it's the introduction to the practice session. Be on time, please. And the others, which are not in the turn A for lunch, can stay here and talk with the sponsors. Or everyone who has still not taken the photo, please do it now. And see you later.